So we're now in section 7.5, and I would like to do several examples with you. I'd like to do 6, 7, 8, and 11. So what I think I'll go ahead and do, I'll do 6, 7, and 8 for this recording. And so starting at 6, and by the way, 6, 7, and 8 are all titled Establishing an Identity. And so starting with 6, I'm going to bring this page back up from my memory, and I'm going to be thinking. I want to start with the gross side. Some of these things I'm starting to put in my brain as tricks, tips that I can use when working on these identities. And so right here, we are looking at example 6. And with example 6, it is cosine alpha minus beta, sine alpha, sine beta. And this is one of those, it should be fairly simple, but if you're not careful when we get to the test, this is one a lot of people will miss or skip. And by the way, never skip an answer, answering a question. Always put something, rewrite it, try something, and usually what happens when you try something, it jogs your memory on, oh, I could use that. And so when looking at this, remember, we're going to look at where are we, where are we going, where are we, where are we going. Well, where we're going actually has some cotangents in it. So that means we're going to need some cosine over some sine stuff. And then we'll have a plus 1. And we don't even have a plus 1 existing here. So I'm going to start with my numerator. My denominator looks pretty good. It's a sine and a sine, and they're multiplied. That's about as good as that's going to get, unless I start manipulating or squaring or something. But this, we've been playing around with cosine and the alpha and the beta. And one thing I haven't done in the recordings is to come back in and say this. On your formula card, do take a minute to find these. This is not a test where you'll be able to use the formula card. You do need to know these. These start showing back up in your calculus sequences or sequence. And you need to note that we do have the sine and the cosine, but we don't have the tangent. So you might want to, oh, we do, because it's already written in on yours. So never mind. You got all three of them. I would double check them. And on this one, it's the cosine. And just a thing to remember, on the cosine, we get to do cosine, cosine, sine, sine. So that's kind of easy. But that means, well, we've got to do something different. So we'll change the sign from a negative to positive. So looking at this, we're going to do a cosine, cosine. And you can't see what I'm writing. We'll change the sign, and we'll do a sine, sine. And that's all over sine alpha, sine beta. And so I look at this and I'm like, oh, great. Look where I am, where I'm going, where I am, where I'm going. I still need a cotangent, cotangent, and a 1. And I look at this and I'm like, you know what? This looks a lot, it looks suspicious, like there's surely there's something that I can do. And so you need to add another trick to your tip page, and I'll go ahead and just write it on the tip page. And so on the tip page, if you happen to have 1/4 plus 2/4, and I know that can be reduced to a half, but we'll just use it for explanation purposes anyway, we would add the numerators and keep the denominators. I know that we would keep going and actually add the numerator and get the 3/4, but I would like to start right here and tell you you have permission to go the other direction. If you have a something plus a something over a denominator, you have permission to write this front part over the 4 over the denominator. You have permission to write this back part over the denominator and put a plus in between them. So just as you have permission to put them together, you have permission to pull them apart. And so that's what we're going to do here. We're going to write these over in one fraction here, and then we're going to add this over the denominator here. So I have permission to pull these apart and put cosine alpha, cosine beta over the same denominator that I'll be using in the other one, plus the sine of alpha, sine of beta over sine of alpha, sine of beta. And this is a great time to ask yourself, where am I? Where am I going? Where am I? Where am I going? We need a cotangent, cotangent. Well, looky here. Do you know that cosine over sine happens to be cotangent? And cosine over sine of the same angle happens to be cotangent. So from right here, we can say we have a cotangent of alpha and a cotangent of beta multiplied together, plus, where am I? Where do I want to go? Where am I? Where do I want to go? I have this first part, and I need a plus 1. Well, y'all look. We've got the same thing over the same thing, and that would be called a 1. We are done with example 6. So I'd like to go ahead and look at example 7. On example 7, again, and we can't see it. There it is. Oh, I've got my little stuff notes all over the place. Well, let's just start right here on example 7. It's pretty funny. Since we've been doing online courses, everybody can see straight into my book and see all my little notes, and I hope they're helpful. Maybe you're even taking some screenshots. So I'm starting here at tangent of theta plus pi, and I want it to just end up being a tangent of theta. That's where we're trying to go. And it just happens to be nice that we're in the section where we're doing sums and differences, and so, you know, let's just take a guess that that's a direction to start. I'm going back to look at the formula page. We're not using it on this test, but I do like, again, noticing stuff over and over and over, how you do it, what you do to put it together, and what it looks like. And so when we had the addition, we had addition in the numerator. We added them. When we had the subtraction, we added them in the numerator. Both of them have 1s in the denominator, and both of them have a product in the denominator, but the sign that we start with is different in the denominator. What we start with is different in the denominator. And in this case, we have the plus. So if it's the plus, we will actually add the 2 in the top, and then in the bottom, we'll do 1 minus the product. So we're going to take tangent of our theta plus tangent of our pi and add them in the numerator. In the denominator, we'll do the subtraction of tan theta, tan pi, and that's a place to start. But again, I'd like to look at where am I going? I'm trying to get to tan theta. I'm not there yet. But I have some of these that I can actually get a number for, like right here. So I'm going to say tangent theta. That one's stuck how it is. But tangent of pi. And so pi is over here at -1 over 0. Tangent is y over x. And in this case, you can't see what I'm writing. But in this case, it would be 0 over -1, or tangent of pi is going to be 0. Well, that's kind of nice, because then that means that part of my numerator is going to drop off. Okay, let's check out the denominator. I've got a 1 and I've got a minus and my tan theta again, but wait, if tan pi was 0 up here, tan pi is 0 down there, and 1 minus something times 0, well, that would be 0. So when I rewrite this, I've got tangent theta over 1, or just tangent theta, and if I go back and check, that's where I'm trying to go. So example 7 is done. So now, moving on to example 8, and you see I've got a whole lot of notes going on in example 8. So I'll cover up, I'll do it this way. And so looking at example 8, it is the tangent of theta plus pi over 2, and it's supposed to eventually equal negative cotangent of theta. And so my brain is like, well, hey, that worked a while ago. I just struck out and started doing this stuff down here, and so I can. And that's one thing you need to learn about identities is start something, and if you end up at a roadblock, don't erase it, just draw an arrow and start over. So I'm going to go ahead and say, wow, that worked out well. I'm going to do it again. Tangent theta, tangent pi over 2, but it starts to smell a little fishy right there. 1 minus tangent of theta, tangent of pi over 2. And then I'm going to go to the next step. Because when I go to the next step, I'm going to do what I did a while ago. Tangent of theta plus. Ooh, here we go. And so if the alarms are not going off in my brain yet, then maybe you can remember when we did the inverses and we talked about, you know, sine is going to be over here and tangent's over here, but you cannot go up to pi over 2 and you cannot go to negative pi over 2 because it's not defined. Uh-oh. So you're saying up here at pi over 2, I'm at 0, 1, and when I go to do y over x, I get undefined. That just isn't going to work. It's not 0, it's undefined. I can't use the same thing I used a while ago. I'm going to leave it written there just so I remember, and I'm thinking on it, and it's like, well, what else can I use? Well, back on our tips, one thing we said, change everything to sine and cosine. So let's try this. Let's go back up here, and tangent can be rewritten as a sine of some angle or a sum of angles over cosine of some angle or angles. So I rewrote it like this. All I did was take my tangent, and I'll even draw an arrow like I said. So we're going to try here and go a different route, because pi over 2 is defined for sine and for cosine. And so now we get to practice both of these formulas. Again, they are here, but you've got to commit them to memory. I'll go ahead and say when I'm doing the sines sum, I keep the sine, but I have to do sine cosine, cosine sine, and I keep the sine. When I go to do the cosine, it's cosine cosine, sine sine, change the sign. So here we go. I'm going to need, let's see if I can keep it in sight, sine of my angle, cosine of my second angle. The sines, they stay the same. Are they different? This is the one where they get to stay the same. And then I'll do cosine of my first angle, sine of my second angle. That's going to be doable. Now I'm going to do cosine cosine. I have to change my sign and then do sine sine. Whew, a lot of stuff going on here, but it's going to be really doable. I still want to take a glance. I want to end up at negative cotangent. So that means I really need to have a cosine something, cosine theta up top, and a sine theta at the bottom, but one of them is going to have to be negative. So here's where I am, and here's where I want to go. Okay, so let's play around a little bit. Let's think. Cosine of 90 degrees. Cosine of 90 degrees, it's going to be based on x, and x for 90 degrees is 0, and if that's 0, the whole thing's out of here. But sine of pi over 2 is going to be 1. So that means we're going to have in our numerator, we're going to have cosine theta times 1, or just cosine theta. Let's repeat this again. I got a cosine times, cosine of pi over 2 is 0. So minus sine of pi over 2 is 1. So minus sine over theta. Where am I? Where do I want to go? Where am I? Where do I want to go? I want to go to cotangent. Well, people, we are there. Because this cosine over sine can be rewritten as a cotangent of theta. And since one's positive, one's negative, we can write that it's negative. So that finishes examples 6, 7, and 8.